Hey, nice to meet you all. I'm really happy to be here. And today I would like to show you what are we doing at Classics. And the project I'm presenting is Kamaji. And what is Kamaji? I'm going to provide you in a glimpse presentation of what is. So this talk is focused on why you should try to build a managed service for Kubernetes. And we saw from the latest report from CNCF that a lot of end users are using Kubernetes, and they are using widely the managed version. It means that if you're running a company and you would like to deploy your applications, you're going to use EKS or EKS or whatever is like Google Cloud Platform, is Google Kubernetes Engine or the DigitalOcean one, and so on and so forth. And why Kubernetes is spreading so much? Because in the end, it's pretty useful because you can build your own business on top of Kubernetes. So you can build a software as a service application, you can do AI or machine learning, you can do edge IoT, and there is also, I would say, a great adoption from the end users because in the end, everybody is using Kubernetes and everybody knows Kubernetes, so I would say. But it's really cool because Kubernetes has been a sort of enabler for infrastructure. It means that you don't need to know all the systems, all the network details and KBITs to build a distributed system. You just need to use Kubernetes. There are so many interfaces like the container network interface, so you can get your applications deployed across a fleet of virtual machines without worrying about the network, about building the bridge networks, the overlay networks, and so on and so forth. So everybody would like to get the managed Kubernetes version, but you have to use the big providers. So we at Classics, we had this idea in providing the same experience that you can have using a managed service. But there are so many problems. And the first one is that there are no tools. It's like in the 2016 with Kubernetes where when you wanted to create a cluster, the unique solution was to run a bash script, a huge bash script, and starting from that, you're managing the cluster and performing the upgrade was a pain. So in that case, the community started working on that because starting from that point also regarding the big adoption of Kubernetes, a lot of tools started rising like kubeadm, cluster API is like one of the latest, and so many other bootstrap options. But keep in mind that also the big vendors like VMware, Red Hat, Rancher, they are building their own distribution, but it's really cool because they are using the setup of managing a fleet of clusters, but they are too much opinionated regarding the enterprise approach. It means that you're going to use VMware Tanzu. I don't want to start a run against VMware Tanzu, it's not my business, obviously. But it means that you have to approach their own way to do stuff. It's like OpenShift. Everybody are using OpenShift, they are saying, yeah, it's Kubernetes, but in the end, it's not Kubernetes. You're using OpenShift because it's something that has been built on top of Kubernetes. And the same applies for other distributions. So there are no tools, there are no solutions out there that are non-opinionated. And we are seeing a lot of the a sizable amount of clusters used by many organizations. And this term is the cluster sprawl. It's inherited by the city sprawl. I'm not sure it's the city sprawl, but it means that when we are in a big city and there is an exponential growth, you can see that a lot of neighbors are started rising across the center of the city, and the same applies also with the Kubernetes cluster. So, because in the end, I saw a lot of customers that were using Kubernetes, and they started spawning a lot of clusters. And so far so good when you start with 1, 2, 3, 4, 5 clusters, but when you are ending up with hundreds of clusters, and there is no need for that, you're ending up in a trap, in the toil trap, because it means that you have to manage the control plane, you have to manage the certificates, the alerts. So if you have been a site reliability engineer, you know that it's a pain. And I will never, ever manage a Kubernetes cluster in my life. But for at least right now, we got Kamaji. So what is Kamaji? Kamaji, first of all, is this character, I don't know how to pronounce in English, sorry for my English. So it's a character from Spirited Away movie. It's a movie, an anime of to say the right term, that I really love. My daughters love that, and also the reality that is my business partner. And Kamaji is the boiler man in this sauna, and he's preparing all the hot water for the guests. So we decided to pay a tribute to this nice character, because he's saying also nice things about all the story. But besides that, let's talk about technical stuff. So Kamaji is an Apache 2 licensed open source tool aimed to build and operate managed Kubernetes service with a fraction of the operational cost. You know what? We saw the rise of CRDs and the operators in Kubernetes in the late 2018, 2017. So essentially, right now, if you would like to deploy your application on Kubernetes, you can do that. It's pretty straightforward. And also regarding the operators, one of the latest addition to the ecosystem is the cloud native PG. So it means that you can run your database on Kubernetes. By the way, we got also Gianluca, that he was managing databases in Kubernetes starting from the beginning. So he knows that it is possible. And we had the same idea. This is the pillars of Kamaji, but I don't want to follow the slides, because I would like to tell a story. You know all that I tell a lot of stories. Because in the end, if you think about Kubernetes, we are using that like a platform to manage our applications. Our applications are made of a web service, some backend services, and a database. So we are feeling confident on getting our applications and getting deployed on Kubernetes. And the question that I had in my mind was, in the end, Kubernetes, what is? Kubernetes is an API server with some components like the scheduler, the controller manager, the API server, and then we got a database. And the database is etcd, the key value store that we are using to store and to persist all the data. So why don't we use Kubernetes to host Kubernetes itself? And the reason is that I think that there is a lot of bias behind that, because it's like a Kubernetes in Kubernetes. It's the qubit section. You're starting saying, why Kubernetes in Kubernetes? It's like the Docker in Docker when we were building the CI/CD pipelines. And I remember that a lot of people say, no, you don't have to do that. But in the end, GitLab is doing that. So you can do that, and we did it. So the pillars behind Kamaji is that we know that there is a component that is the stateless application of the Kubernetes cluster, and then we got the etcd, and I will show you how we are enhancing the etcd. And then we got also a sort of control of the cluster sprawl, because when you got a cluster, well, as a fleet of clusters deployed in a AWS environment, you're ending up with a load of machines, and it means that you have to connect to AWS, query all the requests to the API server of AWS, asking what is the EKS or the managed clusters. We're going to use the Azure one. This is providing also fully qualified domain name. So we have to specify also we are generating additional host names. And then also the options regarding the service seeder, the pod seeder, DNS, and blah, blah, blah. And keep in mind that this is the diagram of what's happening when we deploy a tenant control plane. So with the definition of the tenant control plane, we are ending up with a deployment. The deployment is spawning a replica set, and the replica set is kept busy spawning pods that are mounting secrets and config maps, and then exposing the application using service and egress. It's like a normal application. It's like a WordPress or any application that got a database and front end or back end or whatever it is. And this is the result, but I don't think that you can see that properly. And we're going to do a live demo, and it's demo time. And I would like to get through all of these steps.
So, can we ask some questions, or should we wait?
Sure. So I can trick.
So the first question is, can you go back to the couple of slides? Yes, the two tenants are, let's say, two different tenants.
No, they are the same tenant, but with two replicas.
Okay. So is the concept of the availability?
Yeah, absolutely. Keep in mind, because each API server is connecting etcd, that is out of the equation.
The etcd, you say, is going to be shared to all the tenants that eventually you're going to run?
Yeah. Keep in mind that at Classics we are totally committed regarding multi-tenancy. We developed also another project that is named Capsule, and we are addressing the soft multi-tenancy. You know, shameless self-promotion. Besides that, jokes apart, we discovered that sometimes you need to get the next level of multi-tenancy, and you need different clusters, different APIs, different versions of Kubernetes. And in that case, we thought, instead of dealing with the infrastructure, let's deal at the application level. So this is our answer, our solution to address the requirement of managing Kubernetes cluster, a fleet Kubernetes cluster. So instead of dealing with the infrastructure level, we are using the application level.
Okay, but the ATCD is going to be the ATCD of your Kubernetes instance. It's going to be shared by
all the tenants. It's like the schemas of the database. Okay.
So if that means if a given tenant it won't have a dedicated ATCD.
No, absolutely not.
If the ATCD is shared, why you are not using the underlying ATCD of the Kubernetes cluster?
It could be, you know, the shared ATCD is already a sort of single point of failure. And using also the admin cluster ATCD will be another big single point of failure. So right now, I want to talk about that also because we are still thinking about that. We are looking for ideas, for feedback. So we are going to talk about that, don't worry.
Last question and then I shut up. So if I understood, there will be a tenant, a control plane that eventually can be scaled according to the needs, the same as any other pod in Kubernetes.
Like an application.
Exactly. Same as for all the pod, all the master node that will be kicked according to the need of the resource or the application that you will ask to the API server to run. So same as a standard. The advantage of managed cluster like AKS is that they are also provisioning, if needed, the underlying active virtual machine. So in case the workload will require more underlying virtual machine on the main cluster, how can that be addressed? So it's a separate computer.
Yeah, keep in mind that Kamaji is as Capsule is not a product, it's a building block, it's a framework. So we got customers that are already using that, and we are really proud of that because we are working with them. And it's like the network. So each cloud provider, also the smallest one, they got their own policies, they got their own technologies. So you cannot build something that is a standard way to scale applications, scale nodes, scale virtual machines, and so on and so forth. So our idea is to say, we are providing you a way to scale Kubernetes, the managed Kubernetes, and on top of that, you can provision additional virtual machines, you can do whatever you want, you can install add-ons, you can do whatever you want, because it's not our duty. Okay, it's like an application. I'm just doing one stuff, deploying Kubernetes. End of the story. And starting from that, also with the annotations, with the labels, you can build also, how to say that? You can build a sort of ecosystem on top of that. Using labels, you can say, I would like to deploy, I don't know, a specific add-on just for specific tenant control planes and so on and so forth.
And at the present, is there any restriction on the underlying Kubernetes cluster? So are we?
No. It's going to work. Well, actually, we are still benchmarking all the versions because it's really hard because we need a real Kubernetes cluster. We are using Kind for testing. You know, I'm a big fan of Kind testing. I'm doing everything on Kind, also the local development. But we would like to test extensively. But actually, the Kubernetes, the tenant control plane Kubernetes is CNCF compliant. So if you launch a Sonobuoy or the conformance test of Kubernetes, everything is okay. Also regarding, keep in mind, it's like an application. You just need the deployments, API, the service, and the ingress.
EDI can be any also existing managed cluster that could host the
I didn't get the question, sorry?
Can be also a standard managed cluster, such as AKS.
Yeah. Keep in mind that in the demo, I'm going to use AKS. Okay. The term regarding what's that? The admin cluster that is working as a sort of management cluster is a managed one. Okay, just for the sake of simplicity, it has been also provisioned before starting this demo because it was much easier and so on and so forth. So I'm going to show you how it works. So can you see my shell? Yeah, I think.
Zoom a little bit.
A little bit, yeah.
Okay.
It will be a pain because it's so much big. Anyway, this is the Kubernetes cluster where we got our Kamaji. So how did we install Kamaji? Using Helm. We got the Helm chart, you can pull the images, you can install specified parameters, and so on and so forth. And inside this namespace, you can get the Kamaji pod, that is our operator, and the etcd. So with the etcd, we got obviously free replicas. We already enabled the multi-tenancy, we granted the roles, and so on and so forth. So in the repository, we got all the requirements on how to set up properly the etcd. With the latest version of the Helm chart, everything is done by Helm, and that PR was a pain, honestly. So, what are CRDs? So essentially, we are going to get the tenant control planes CRD, where we can get it explained by Kubernetes. So everything as usual. I already created also in Classics, Kamaji, CNCF Turin, some manifest. Okay, so let's take a look to manifest 10.0.1, and as you can see here, we got a deployment. Let's go for 2 replicas. We are going to expose it using a load balancer. And no ingress, we are using the version 1.23.1 using systemd with these admission controllers. And I'm expecting to get then also a certificate, well, not a certificate, but a fully qualified domain name like 10.01, that is the service name with West Europe, Azure.com, because this AKS cluster where Kamaji has been installed is in the West Europe region. And then we are setting up also the add-ons like CoreDNS, keyproxy, and connectivity. Who knows what is connectivity? Wow, something that you don't know, I know. Yeah, that's great.
I know it by name.
Yeah, it's really interesting connectivity. I discovered a lot of stuff doing open source, and I'm really happy for that. Anyway, this connectivity is a server that is going to be presented using a load balancer on this port. So what I have to do, I have to switch on my default or any namespace I would like to use and issue kubectl apply -f manifest tenant01. And then meanwhile, I'm going to watch what's happening with the tenant control plane. So as you can see here, we are getting up with a Kubernetes cluster that is in provisioning state. And when the service with the load balancer will be provisioned, we are ending up with getting the control plane endpoint. It means that if I query that IP, a Kubernetes API server is going to reply. But obviously, I need a kubeconfig. And this is the secret name of the kubeconfig that I have to use to connect against this tenant control plane. So in a matter of 40 seconds, because images should be already cached, it should be ready, and it is. We got our Kubernetes cluster deployed. So how to retrieve the kubeconfig? Well, we got JQ, yeah, this one. So I'm getting my secret tenant01 admin kubeconfig in JSON. I don't remember how to output the JSON from kubectl, so I'm using JQ, reading admin.conf, base64 decode, and storing in temp tenant01. Okay, the file has been written, as you can see here. So we got our certificate authority, we got our server, we got our name, the context, and the user with the certificate, and so on and so forth. So if I now export the kubeconfig to this file, it means that I'm using the kubeconfig stored in temp. So issuing kubectl version, and as you can see here, we got 23.1. So it means that I'm getting the request exposed, well, it's passing the load balancer and is getting forwarded in this set or the virtual machines that are hosting my cluster, and it's cumbersome to manage. And the idea is to say, in the end, you're getting with a Kubernetes cluster where you're getting where are you deploying the tenant control planes, and end of the story, pretty straightforward, like an application, like an instance of an application. But how we are doing that? So essentially, we are doing that using a shared data store, and the data store is etcd, the key value store. Starting from the version 3.5, it has been introduced a nice feature that is the multi-tenancy. So I don't want to deconstruct it, but in the end it's just a namespace. So it's adding a prefix to the key that you're looking up in the key value store. So it's like a schema in the database. So you can have a single instance that got a lot of schemas, and starting from that, you can create many installations of Kubernetes on each schema. And as I said before, also this is the Kubernetes inception, so Kubernetes in Kubernetes. So this is the architecture. First of all, we had to get acquaintance with the terminology, and we are using the admin cluster to identify the Kubernetes cluster that is hosting the etcd installation and the Kamaji operator, and as well also the tenant control plane pods. They are not nodes, they are pods, because this is a Kubernetes cluster. So we got our etcd deployed in Kubernetes, and keep in mind that for the sake of simplicity, we are using an etcd deployed inside the admin cluster, but you can get it deployed away from the cluster. It's not a big problem. You can use virtual machines, you can use physical machines, it doesn't matter. You just need to get it connected to it. And then you got the tenant control plane pods that are announcing themselves using an IP address, and then you got the worker nodes that are connecting using this IP. So we got the data store that is the etcd multi-tenant, we got the admin cluster that is hosting the etcd, and also the tenant control plane that are pods, and then we got the node pools that can be deployed on AWS, on Azure, on your cloud provider, or even your virtual machine on your laptop. Obviously, it must be reachable by internet. So, what are the benefits of Kamaji? Obviously, I'm trying to say that, so that's the reason why I'm saying, yeah, there are so many benefits. The first of all is that when you deploy on Kubernetes, you are sure, in inverted commas I'd say, that the application is resilient, and you're going to perform a cost optimization, because you can think about the tenant control plane are essentially pods, and pods are more convenient rather than a virtual machine. When you deploy a tenant control plane, you have to consider the route consensus. It means that with etcd, you need at least 3 virtual machines or 3 instances to to manage a failure, because there is the route consensus. Instead, if we can decouple the API server, the controller manager from the backing storage, and delegate the backing storage to another component, we can decrease the cost, because a pod is like a container, is more convenient than a virtual machine or a machine. Then, obviously, it's an operator. It means that you don't have to do anything. Everything is declarative. So everything, when there is a drift of the configuration, Kamaji starts the reconciliation process. And last but not least, we are going to install a CNCF compliant Kubernetes cluster, Kubernetes application. It means that we are not using these pods, because we got our deployment, we got our service with tenant 01. Pretty straightforward, okay? So what I can do is to also edit my tenant control plane and say, I want to change the version. It's like I need to perform an upgrade. So what I have to do is easily to go in the section version and say, let's go for 123.2. So as you can see here, we're entering the upgrade phase. It means that I'm getting with a different pod that is pulling the images, and when it's going to be ready, it's going to be switched off. You know, it's like the classic load balancing in Kubernetes. When the new pod with the new version of Kubernetes is up and ready, we should see that the version is going to be changed here, and here it is. And it's like an application. So when you deploy a new application, you're performing a rolling out upgrade. The same applies also with Kubernetes because it's a pod, it's an application. But if I export again the kubeconfig and I issue kubectl get nodes, obviously I don't have any node. Why this? Because I have to deploy, I'm entering an AWS and my idea is to spawn some virtual machines on AWS, and these machines are going to join tenant control plane. So I'm entering in EC2. I'm sorry, I'm not using an automated tool. I'm not using Terraform. Blame on you, blame on me. But you know, guys, I drafted the demo this early morning, and I was really tired, also because of the heat wave and so on and so forth. So I got an autoscaling group that I created. So I'm using an Ubuntu image. I'm installing containerd. I'm installing, I'm disabling the swap, and so on and so forth. All the actions that you're performing when you have to bootstrap a node, a worker node. So what I'm going to do is to select it and say edit, and I would like to get 3 nodes. And I'm updating it. And now we have to wait for the nodes for getting up. Just joking, virtual machines are slower than Kamaji. Just bragging. Let's wait for them. Let's go here. It's running. Okay, it's running. So, no security groups, SSH directly. And I'm showing you what I'm doing here. So var log clouding output log. So it's updating a lot of stuff and it's installing all the required components like kubectl, kubeadm, and I don't remember anything else. Kubectl, kubelet, also kubelet, yeah, also kubelet. We have to wait a few minutes.
But this is done by you or automated in some way by...
I'm using a user data on AWS. It's a cloud script.
But Kamaji is not supposed to.
No, because Kamaji is just spawning the control plane. But
so the node should be already...
Yeah. Kamaji is just doing that stuff. I need an API endpoint. And so, because I'm using AWS, but let's imagine I would like to use Azure, I would like to use DigitalOcean, I would like to use Vultr, Sibo, or my own home-built KVM server. In the end, it's much easier that you're saying this is the API endpoint that you have to use, end of the story, and I will show you. So we are here because everything has been configured. In fact, we got CryCTL, and what we have to do right now is to again export the kubeconfig for the tenant control plane. This one where we are using 23.2, and now I have to generate the kubeadm join print command. So kubeadm, I would say that it's a bold statement. It's the standard way to manage a Kubernetes installation, and we truly believe that, and I will tell you why that. So with kubeadm, I'm creating a token, and this token is printing the join command that I have to launch in the EC2 instance. So I'm copying that, and since the host name is going to be used by the kubeadm, I'm appending also the node name. So in the end, this node is going to be presented using its public IPv4, because otherwise the control plane wouldn't be able to communicate with the node, obviously. because it's not routable. IP 002.176. So with that said, we are launching the kubeadm, and kubeadm is performing the kubelet configuration. It means that it's generating the request, well, it's asking for the certificates, downloading them, configuring the kubelet, and in a glimpse, we should see here the node that has been deployed. So this is the node that I just deployed here, but we are missing something. Why is it not ready? Question time. Why is it not ready?
Networking.
Networking, yeah, exactly. We are missing the networking. That's the correct answer. And the reason is that we need to use a CNI, and honestly, I'm using Calico. That should be this one. Yeah. So, I'm going to issue kubectl apply -f Calico or Calico. And now, if I try to watch for pods, you can see that we are downloading a lot of stuff. So Calico is performing the CNI setup, is launching the node setup, and we should see everything configured in a matter of minutes. In the meanwhile, what I can do is to connect to the other nodes and perform the same action. So connecting here, getting the public IP, I don't remember. kubeadm. This one. Maybe it's much better to copy that here. Oh, crash will back off. That's great. Why that?
Maybe try turning it off and on.
I'll do that, absolutely. I can try to debug that, honestly. So, let's give a try. I don't remember, should be this one. Try CTL. Yes. Proxy is there. I can take say, yeah, should be everything's fine. Try CTL yes -a exit y. Try CTL logs -f. Does not exist. Oh, that's weird. Anyway, it should work, guys. Trust me. It was working at all.
Neither on your machine.
Yeah, absolutely.
Plenty request.
Yeah. Do not find the requested resource. Just pulse here these. Get IP pools. You know what? I don't like this version of Calico I was using. Was which one?
Go for Cilium.
Oh my gosh, no.
It's gonna take a day.
Let's delete everything and let's use the Calico one on premises, the official one. At least give a try. There should be this one. Let's see here now, because keyproxy is working. Let's see if the Calico nodes are getting up and running.
Right.
Yeah.
Music ends.
Ukraine. I was waiting, guys. Sorry. So now I should get all the nodes ready, and everything is ready. I don't know why. I was using the wrong manifest. You know, shit happens. So it means that also from my machine, from the tenant control plane, I can get the logs of the remote pods running in the nodes, in the AWS nodes. What I have to do is to issue kubectl -n kube system logs -f the name, and here it is. I can get the logs thanks to this component. Oh, connectivity. Because with connectivity, we are creating a reverse proxy. Well, I would say a reverse shell from the AWS node against the API server, and starting a bidirectional communication from the API server. Because when I get the pods, when I request the pods log, the control plane is starting a request against the kubelet. Yeah, thank you. Against the kubelet. But if the kubelet is not natted, doesn't have a public IP, or is living outside of the virtual network or the network of the tenant control plane, I cannot get that. So connectivity is just a tunnel in order to retrieve the data. And with that said, it means that, as you can see here, I get the nodes of my control plane, but these are not nodes deployed inside of my AKS. So essentially, I'm offering a sort of managed Kubernetes service, I would say, because if you take a look also to the pods, there are no API server, no controller manager, no scheduler. Yeah, you got the proxy, you got the connectivity because they are add-ons, the CNI that has been provisioned. Yeah, go ahead.
Did I see that right? That you have worker nodes on 122 and control plane on 123?
Sorry?
Is it correct that you have the control plane on 123 and the worker nodes on 122?
Are you pointing to the IP?
The tenant.
The version, the Kubernetes version, yeah, because I didn't have time to prepare properly the version. Yes, there is a version skew, yeah, my bad. But keep in mind that it's working, although you shouldn't use that, you know. But yeah, it's working, because I didn't have time, sorry, due to the COVID and all the stuff, but yeah, it's working. So, with that said, what I can do in the tenant control plane is also to upgrade, well, not upgrade, but upgrade install capsule, that is our also project. And with capsule, we are installing CRDs. So it means that I'm ending up with my CRDs because the API server is just used by me. And in the meanwhile, what I can do is also to enter Kamaji, CNCF Turin, and apply another tenant. So I can have multiple tenant control planes using different versions, each one with their nodes. And what's great is the end that also the webhooks are working thanks to connectivity. So the tenant control plane can communicate on the nodes. And with that said, I think that we completed the demo. And this is the roadmap that we got in plan for Kamaji. So obviously, we have to benchmark and stress it, and we are looking for feedback, we are looking for adopters. So if you would like to give it a try, we are really happy to try to help you. We are also on the Kubernetes official Slack workspace. We got a channel that is #Kamaji. You can reach out there, and we are going to help you. And besides that, we truly believe with kubeadm as standard tool to manage Kubernetes clusters. And with that said, we are working also to provide the cluster API. So the question that I remember maybe you, Cristiano, asked me, or maybe you, I don't remember. Anyway, how to provision the worker nodes? Well, if you got the cluster API provider, you can say, I would like to spawn virtual machines on AWS. I would like to spawn the control plane on my Kamaji instance, and I'm using cluster API, declarative management, so you don't have to issue all the commands as I did, although you can use automation like Terraform or anything else. But cluster API, we truly believe that this is the right tool to manage Kubernetes at scale. And also because
API for managing the underlying Kubernetes.
to manage all the fleets of Kubernetes clusters managed by Kamaji. So in the end, keep in mind that with cluster API, we are ending up with multiple clusters, because cluster API, you're using that to manage a fleet of clusters.
But those are, let's say, virtual cluster. The one you have to scale.
With Kamaji, with the Kamaji cluster API provider, you are just provisioning the worker nodes, you're provisioning the virtual control plane, the tenant control plane, and the nodes are joining the tenant control plane. Okay? Don't worry, as usual. Just joking. sorry, I was just joking. You're so smart. Anyway, I'll tell you later, don't worry. Then we are also working with the Prometheus integration, because obviously it means that Kamaji can be a critical component for infrastructure, so it means that you must have alerts, rules, and so on and so forth. And also regarding backend storage, next question by you. I remember that by you, Cristiano. So right now we are using a single instance of etcd, although spawned across 3 instances with the replication. But we are still evaluating if starting a pooling of the etcd, because we know that etcd is great. Well, I don't know if it's great, because there are so many limitations of etcd. It's fast, yeah, but it cannot scale. And the issue is that there is a limit, an hard limit regarding storage. It means that you cannot create an etcd cluster bigger than 8 GB of storage. Above that threshold, hic sunt leones, so you don't know what could happen, okay? With that said, we think that there is a nice project that is named Kine, and Kine has been deployed, well, not deployed, but developed by people working at Ranger. And Kine is a nice integration because in the end, you can use a different backend storage. So it's a sort of, if we have to talk about patterns, it's a sort of ambassador or sidecar container that is translating the etcd signatures to PostgreSQL, MySQL, SQLite, SQLite, and I don't remember with anything else. So we know that etcd is not a viable solution to work at scale. If you need to work at scale and you need to be sure that the data of the customer, because you're storing everything in etcd, are safe and replicated, you can use PostgreSQL, you can use MySQL, yeah. We started with MySQL, but we are also working with Postgres because it's just a matter of dialect. But we are in that direction because we strongly believe that in the end, Kubernetes is just like an application. We all know that, oh my gosh, Kubernetes is so complex. Yeah, it's absolutely complex. It's a framework. But in the end, you can manage that like an application. So this is the roadmap. So if you would like to get feedback about that, we can talk about it. We can talk on GitHub, also in real life right now, or whatever you want. So these are the contact links. We got our repository. It's totally open source. So you can fork it, you can pull, you can apply, you can do whatever you want. You can join also the Kubernetes Slack channel. It's #Kamaji, and thanks so much. I think that we did everything.